Hi everyone, thank you for being for this session about Kotlin and dependency injection. I'm Arnaud Giuliani. As you may hear, I'm French. I'm a mobile developer and also doing some backend, and I'm the lead maintainer of the Koin project. Before starting and trying to dig into really code snippet and stuff together, I would try to start with the first embarrassing question, and yeah, this one. Why? This, in let's say that two years ago, people were asking that. Yeah, why are you trying to make another dependency injection framework? And to give you a clear answer, I have to go back in 2016. In 2016, we had this Kotlin 1.0, first programming, the first stable version of Kotlin, and then it was production ready. And it was tagged production ready by JetBrains. I tried to put it everywhere in all my apps I have under my hands, and you can also ask my colleagues about that. But when you try to unlock all your Kotlin features, and this was the first one that you had in Kotlin 1.0, you clearly begin to feel like a superhero because, yeah, we begin to write very super things. But around, the ecosystem of the tooling and stuff is still really driven by Java, and we have lots of good things. Java made lots of good things, but once we have made things with Kotlin, yeah, we want to go a bit away from this heavy syntax and stuff. And yeah, can we make something else than trying to annotate everything we want here in the Android application stuff? And at the beginning, and even if you want, with Kotlin in your Android applications or little applications, you don't need DI because you have objects. This is singleton object class. You have functions, generics, lazy delegates. You can really have fun to write that, and it's really good. And you still can find some article about that, about making manual graph for application. But you will see that with time, it begins to be really bit problematic to have that. And yeah, I was looking for something really simple, and simplicity is for me the key of the productivity for me and my team. Then yeah, I didn't find it in many of the tooling that you have on the market. And yeah, this was the stuff to say, I want something that is clearly focusing my needs in terms of developer, not ditched by theory or over-featured, but I don't understand that I will never use. And I want something that I can simply read and understand quickly, and something I can write just behind that. For that, I would like to see with you an application to make coffee. Perhaps hope you get some coffee here to see this session, but let's see how we can have the coffee maker app, and also perhaps some of the people here seen that with the Dagger sample stuff. But okay, we will have a very simple application to make the coffee, and this is the practical example to make dependency injection. And what's about? Then we have a class, coffee maker, and we have a function, brew. And then what we want here is just having another component, the pump, the thermosiphon one, an implementation of pump. And then we want also her heater that will heat the water. And what we want here is that we want to use those dependency, those components by their interface, not directly by their implementation, and use them in our coffee maker that will make the coffee. Then the coffee maker we'll call the pump to pump the water, we will hold the water, etc., etc. And then also we have this dependency between the thermosiphon and the heater here, because we want to be sure that we are pumping hot water. We will see some pure Kotlin code, nothing, no framework, nothing here, just pure Kotlin to show you how this application can be written very simply. And then for that, we begin with the heater. This is just a Kotlin interface. We have three functions. On, off is hot. And then this is the implementation here. Then we just have a backing property to say that we are hitting the stuff here. But then we are saying that it's on. We are writing the ASCII code here. The off, we are not hitting anymore. And we can say if the water is hot. This is the most complex class of the application. Then, okay, we can hit the water. We want to pump. Very simple interface. And then what we are doing here is in the first implementation that is taking in constructor. Here the constructor class of thermosiphon that is using directly a property, heater. Then we are not using the implementation, directly the interface. And we will use it to verify that the water is hot. And then we can pump it and print a little shiny ASCII stuff here. And to finish, the coffee maker class, the same thing. Coffee maker class is using by constructor the two components here. And then we can make the coffee. That means that we are calling the heater, we are pumping the water, and then we can print, yeah, we had the coffee, and that's it. We can hit off the stuff. And that's it. That's it. We have the three classes, two interfaces. Yeah, that's not bad. And this is not finished because we need to bootstrap. That means that we need to get those instances to run it from the application. And we need an app. Here we have a class to run that. This is the coffee app. We will get the instance of Coffee Maker. Yeah, for those who see that it won't compile like that, we need something because here we have to initialize the value of Coffee Maker, but we will see later. And what we want to do is to have a function run to run all the process with directly the components that we have. And this is the question: how we assemble it. And assembling, making dependency injection, what is it? It's about asking an external system, an assembling system, to say, okay, give me this instance, please, and assemble it for me, and give them in my application. If I take back those three classes without their body, I can write them like that, just to see their dependency and about their properties and stuff. And what we can do is that if I write that just in pure Kotlin, I would say that I just have a heater, a pump, a coffee maker, and I can just write this kind of really simple boilerplate here. What I would like to have is something that could help me inject this out of my injector word that could be written like that, because we are making Kotlin and then we can pass argument like that, which is the same as that. That means that, yeah, we want to say to this kind of injector component to say, okay, give me this coffee maker, okay, and do the other stuff yourself by getting the components. And then the injector will deal with this instance by itself, and I don't want to care about how it does, and then I just want to get my coffee maker stuff. And the idea, the intuition behind Koin was to say, okay, just in very simple way, I have two definitions of my components. If I make them as a function, that means I want to build something, this is function to build an instance. Then the idea is to say, okay, I just need something to link them, to link two functions, to use injection of the instance in one of the functions. And then we have a kind of get keyword that is one of the main points of Koin here. And then what is Koin? Koin is a DSL, Kotlin DSL. That means it's pure Kotlin. It's compiling with your code. And this is running behind a lightweight container. That means just think about something that is very small and is running your functions for you. And we are just looking what is your definition. Say, okay, this is the coffee maker, and we need this definition for you, and that's it. And we want a really simple API for you to use it for your daily developer stuff. And everything is in pure Kotlin. The idea is not to reinvent the wheel. Just the idea is to say, can we have something in between all the stuff that we already know, between generation, reflection? Can we do something a bit more with this open feature that Kotlin offers us that are the functions, and then can we do something with that? And if you want to make just dependency injection for a simple Kotlin application, you can just use this Gradle dependency, Koin core, org.koin core. And then you have access to the main feature about this dependency injection framework. And then it's purely standalone. We can embed it after in any kind of runtime framework. But let's start with how we can describe those components, because we just have to write components in the DSL and that's it. We could retrieve them easily. What we have to do is to say we declare something. We declare our definitions somewhere. This is the module. The module just you have the module keyword and just open a lambda, and you will have things that you want to declare. Is let's say that mostly you will have single or factory. Single, you will declare singleton, and factory is something that will be created each time you ask for it. And after that, you see that you have brackets, and then this is also a lambda to tell you to describe the way you want to build your instance here. And that's it. You have a space to say, this is my component, this is the way I'm building it, and this is where I need to ditch my instance. And let's get back to those three classes, and then we have a module. We can declare a module just directly in a value. It's an immutable value here. And we can say, okay, let's declare the first component, the electric heater. Okay, we can just say single off, directly calling my constructor in this function. In Kotlin, we don't have new keyword. We just call directly the constructor here. And then that's it. This is just a function that is building the instance of electric heater. The only thing that you have to take care is that we don't make magic things for you. We don't make reflection, as it has to be embodied in a very lightweight runtime. Then we don't want to make runtime for you. And then you have to be explicit in terms of type. That means that if you want to retrieve electric heater by the heater type, you have to write it directly after the single keyword here. If you don't specify any type, it will take the type of the expression that you have here. Let's go for the thermosiphon. We want to declare a thermosiphon instance, and we want to make it as we found a pump instance, and it will be Kotlin code in your code. And then the compiler will say, okay, you forgot something here. You have to give a value to your constructor. And this is the last keyword that you have to memorize, is that it's get. Module, single, factory, get, 4 keywords. And just here, you just say to Koin, just resolve this for me, please. And Kotlin is smart enough to avoid you to type to specify the type everywhere, then it can guess about that. Then this is how you make the injection between electric heater and thermosiphon. And let's finish with the coffee maker. We just have a single of coffee maker, and we just pass get and get to resolve the dependency of the other components, and that's it. Very straightforward. People reading that understand how it seems to work, and you can rewrite it directly. You can split modules about the usage and everything you want, depending how you want to organize stuff, but Koin is runtime. We won't check dependency and definition for you at compile time, but we have tools for you to help you understand how you can verify graphs. And then we will see later that we have tools to let you verify that your modules are working together. Aside of this DSL, we have one of the main components, one of the main concepts in Koin, that is a Koin component. That means that this is a class that is allowed to use the Koin container. And what is it? This is an interface, okay, just a marker for us and for you, because it identifies the fact that you are linking yourself to the Koin API, okay? The Koin component will be a component that is allowed to take an instance in the Koin container. Then you are depending on the Koin container. And this is very important for you to understand that. But for us, also, it's a convenient way to provide extensions for Kotlin and then give you access to inject and get on the fly when you want, where you want, and then retrieve this. We don't want to allow any, let's say, wild static access to the Koin container. We really want to identify this linking to this API. And the Koin component is the main concept that allows us to bootstrap the application and also to help us integrate any kind of runtime, like Android, like Cater, like Tornado FX, many of the runtime that we can enrich just by extension like that. What does that mean? That means that for my class here, if I want to get my instance of Coffee Maker, I just use Koin component interface. I extend Koin component interface, and I have access to by inject. That is a lazy delegate. That means that Coffee Maker is lazily evaluated, and it will be injected only when I will be used that. And that's it. You have one interface, and then you have access to the container. Then, okay, we need to start the container before you are running the application, because else you won't have the definition somewhere. Then we need a starting point here. This is the main function that you can have in very simple Kotlin applications. And then what we are doing is say start Koin. Start Koin is the function that starts the DSL to say what I'm doing in my Koin application. And mainly, the almost only thing that you will do is say that you are using modules. And if you have multiple modules, you can just separate it with a comma. And after that, that's it. You have started Koin. It's just reading your definitions in your module, and that's it. After that, you can run your instance, run your app, and you have your coffee. Yeah. Great. If we want to go to the extreme stuff and see that finally this link here is lazy, what we are doing in Koin is not reinventing the wheel again. We are just reusing Kotlin, and if we just need a lazy evaluation of dependency, we can say just lazy of this expression. And then my dependency here will become a lazy header, and then will be injected by delegate by the stuff, and then I can use it directly here. Let's go to the Android world and understand how we can play with that directly. And just to remind that finally, in Android, we can't create Android components directly like we are creating new class like that. We have to conform to the Android lifecycle to be called by the system. And then what is Koin offering is that we are getting Koin extensions for Android for your activity, fragment, and service. And then we give extensions to make them as Koin component directly out of the box. And which is very cool, because you just have to use, this Gradle definition, the Gradle dependency, Koin Android, and just by adding that, you will have access to Koin, and you can have access to extra functions that allow you to have Android logger and Android context. That means that here you just have two specialized functions for Android to say, okay, here in the Android context, I want to inject the Android context somewhere, then you have to write it at the beginning. But that's it. You just run your modules. If you want to log Koin in your logcat, then you just specify Android logger, and then after that, that's okay. And in your activity, what you will have to do is that you just declare a val, which is interesting also because it's an immutable value, and then you can just write by inject. Yeah, fairly simple. You just write your module in your activity, just say by inject. If you want to play with the Android context, then don't forget this line, and then when you will have to write your definition, you can describe it like Android context instead of get, or also you can write get if you are a lazy person, but depending on yourself. Then you can resolve directly the component here, and you will have access to your Android context directly. One of the other case here is that in Android, we are dealing with transient component. That means that these components that can't be singleton because they have to be destroyed with your activity, along with your activity or stuff. Then, for example, for people that are writing MVP or a class like that, we can write, if we have a presenter, for example, that is using the coffee maker activity, then what we can write is that we say factory of my presenter. That means that it will be recreated each time I want to ask them. But here, the magic will be that my activity will ask my instance just the first time, and then it won't ask again for the creation of that. It will ask again when your activity will be destroyed, and then you will ask again about the creation of your presenter. But mainly that will cover your need about that. One of the best feature that people like in Koin is that very quickly we have been ready for the Android architecture components and mainly for the Android view model features. That means that just use this Gradle dependency definition, and then we bring Koin extension for the Android view model. That means that you have a view model that you begin to write here, my view model class. You just extend view model, the Android system class, and you can use directly here constructor. And in your module, what you have to do is not use single or factory. We will use a special factory keyword that is view model, and you just say view model, and you resolve the thing that you need. And then you don't have to write your own factory. Just one line, and you say, this is the instance of my view model. And in your activity, what you will have to do is to declare a member, a property member, directly, not by inject, but by view model, because this is a specialized dependency injection that we have to plug on the factory system on Android to give you and keep the instance for you. But then, you just declare one line in your DSL, view model, and then you have the view model instance. You can use the constructor injection directly, and that's it. This is also available in Fragment, which is very cool out of the box, and which is very nice is that you can use a shared view model instance, which is very convenient to communicate between activity and Fragment. And then we will ensure that you are using the same view model instance for your activity and fragments. Okay, then that's all for the Android world, mainly. For people that want to play with the Ktor web applications, we have a bunch of stuff here, and then we have a Koin Ktor and Koin Logger SLF4G. This is a specialized logger bridge for SLF4G. And mainly this won't be difficult at all also, because what you want to do is, for example, start your Ktor application. Here's a way to start the Ktor application. What you have to do when you have to install your feature in Ktor, and you have, for example, just a first routing of your path here, then what you have to do is just use install Koin. It will be the same as start Koin in your Ktor application. You can use this SLF4G logger. You can specify the modules that you are using, and then that's it. You have this locator about injecting the dependency of your coffee maker instance, and then you can use it directly here. Ktor don't have any DI integrated. They let people do what they want, but then in 2 lines you can add your components and add your instance like that. And then we bring extensions for Ktor for application root and routing functions, and this exactly the same. We are making them as a Koin component. The other things is that for Ktor, and we'll come back on that, is that instead of writing functions, we can just reuse a reflection API that we just keep for the JVM application runtime because it uses reflection, but then it's less verbose to use for them. And what we can also use is that we can say at the beginning of my server, I can say create it at start, and then Koin will create my instance at the beginning. Fairly simple to use then. One of the most important parts is that you can easily test with Koin. And you just have to use the Koin test package. And the first thing that you have to check with that is that check your modules. You are writing modules, then it's very interesting that you check your modules and everything is running fine. And how you do that, you just use a JUnit, you just start Koin, the modules that you are using and say .check modules, and that's it. In a JUnit, you can run and check every dependency graph, and you can keep it on your CI and stuff, and you will be sure that your application won't break on runtime and you won't have any bad surprise. The other stuff is that we are bringing extensions for JUnit and Mockito. That means that if I want to play with Koin with a JUnit, I want to start Koin like that, which is fairly okay, but I have a special Koin component interface that is specialized for the test, that is Koin test. And then I can have access to my instance directly from Koin. I can play with that, but also I can declare a mock instance of a given component directly on the fly just to make sure that I want to play with this stuff. And it avoids me to rewrite modules, specialize with mocks and stuff, etc. I can just say, okay, run my app, and this will be a mock, and I want to be sure that I'm verifying some stuff about that. I can run the brew functions to give the coffee, and I will be sure that I can verify directly my eater instance that had been declared as a mock directly on the fly. Yeah, that's pretty much it about Koin. After that, there is lots of side topics I would like to share and we can talk about, but yeah, not much time for that. But first, just to know that Koin is in its version 2.0 since June, and what has been important from the beginning is that with the feedback of people, since the first version, the DSL was clearly something people appreciated, because when you look at the sample, you just need 4 keywords to understand the DSL. After that, the API stay until the first version, stay completely pragmatic, as we just want to play with get, inject, Koin component if you want to use the interface. But mainly after that, in this 2.0, I've been rewriting the engine and the container to just make it completely as fast as as the other market tool. And one of the contributors helped me understand the benchmarking on the other dependency injection framework solution, and then it gave me some results about the first version, and then it pushed me to rewrite mostly of the engine, keep the API, keep the DSL, because this was the good things, but we were required to go to something clearly faster. And if I want to compare something, for example, the coffee maker app that we could write directly here, what I'm doing is that I'm measuring timing for every portion of code. That means first time I'm measuring the starting, second time I'm measuring the first access of the maker instance, and second time I'm measuring the second access will be already cached because it's a singleton. I want to compare it to another tool that is compile time dependency injection, that is Dagger. And then because most of the Koin user are using it for Android, it was important to show them that finally this solution can go very quickly. And if you check the results in terms of timing, it was very interesting because the usual access of the object are almost the same time. That means that it's 0.07 milliseconds. And the only thing that is really the difference is that finally, yeah, there is no magic. Dagger is preparing the compilation for you, and then what you are doing is that you are locating a class in your class path to get the proper factory. Koin is just locating the definition for you and running the function for you. This is the difference. Then Koin has to read the definition, and it has time. And fairly, we have benchmark where we try to benchmark, for now, we try to benchmark applications with 400 definitions, which is already quite good. And you will see that finally it's loading, it's 12 milliseconds, not bad. And if you really have problem with loading and stuff, and you clearly believe that perhaps Koin is getting slower at the startup time, depending on devices and stuff, you can split. You can split your modules, you can load stuff after that. But yeah, I think this is not really the big issue that people could expect. If you want to find the benchmark about Dagger, Koin, and stuff, and all the dependency injection that has been tested by Sloy here on, I forgot the stuff here. You can find them here. If you want to see the changelog about Koin 2.0, you find here .bit.ly.ready for Koin. Let's talk a bit more about Koin and a bit more about the container. And yeah, if you want to make the internet throw in flames, just put those keywords and Koin and you will see Twitter got flamed instantly. What I will say is that dependency injection service locator, with Koin you will use those two patterns. And why? Here, for example, we are describing our components in your module, and here you will use mainly constructor injection. Your class are not depending on the Koin API. You are not using any kind of import into those classes. Those classes are created by Koin, and then you have access also to the functional DSL. This is dependency injection. At the opposite, here we have a class that is asking for the instance. This is the host class. We are not creating it directly. And Koin will retrieve the instance for you. And we are asking Koin to do that with the by inject definition stuff here. This is the service locator. And then, is service locator a bad thing? You can find many articles tackling about this. And this is not, I think that with the evolution of language, you can't compare things anymore like that. And for example, if you want to compare things like service locator, that means that for your property, you are actively retrieving the instance. What are you doing when you are using ToSpeak, Dagger, and stuff that are making setter injection directly here? You are also asking your dependency injection framework to fill those definitions. But this is not the same way. On the first way, you are getting it property by property. On the second way, you are asking for a setter injection. This is why people are making the difference between that. But after that, yeah, if you want to call Koin service locator, up to you. I'm not here to force you to think about that way. I just show stuff. And finally, you will see that most of your writings with Koin will be configuration. And you will have 20% around about platform extensions. And the idea is to try to write everything in your module as much as possible. And yeah, if you want to take back to the foundation article about Martin Fowler, who was the first to talk about dependency injection, in the end, when he talks about the two solutions, he says that the most important thing is not really the concept. It's more about the configuration and what we are doing with that, and clearly separating the stuff. Okay, now let's continue, because I talk about functional dependency injection. Yeah, you will see that finally we are using the functional aspect of Kotlin here. When we are using those modules with definitions, if you try to open the source, we have something like, yeah, it's a function that runs on a scope and can have definitions, parameter, blah, 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 etc. The things to keep in mind is that we are getting your scope, your instance of Koin, and you're getting parameter, and we can make stuff by your function. And the thing is that clearly we are putting here the possibility to add you more expressivity with this DSL. And first of all, for example, we have the way to inject parameter on the fly. For example, I have a presenter, and what I usually do is that I have a function to say manually set ID. Okay, but this presenter is just related to this ID, to this stuff. What I would like to do is I can pass directly the idea as a parameter of this function directly to my instance, which is fairly cool. And when I want to retrieve my dependency, my instance, what I have to do is that I just open a lambda behind the inject. I said, okay, this is parameters of, this is my parameter to inject my instance, and that's it. And then I can pass my string here to go to my presenter. Yeah, very cool. And this is the same, you have access to that for the view model. That means if you have a view model with, for example, some constant in this constructor here, you can use also the parameter injection. And what you have to do is the same way. You will have to open a lambda behind the by view model stuff to say parameters of, and then you will inject the value to your functions. It's a convenient way to pass stuff directly to your instance and definition in a short way when you need it, and can have a really good use case for that. We can also have reflection for JVM related stuff, or people that want to get rid of this get stuff. And also I've seen application when people have more than 5 or 6 property to inject. I say, yeah, begin to think about why you need so much dependency in your components before saying that you want to get rid of that. But if we want to get rid of this function stuff and resolution with the get keyword, we have to we won't be able to use this functional dependency injection stuff. This is side component module, the Koin core extensions. We are putting extensions and experimental features here, and the idea is to say that finally, instead of having to declare all those definitions in function, we could just declare directly types, and by reflection, we will have to make the magic for you. But there is, we are making the stuff for you. And for example, for all the JVM application directly like Kato or Tornado FX, it won't have any much impact more than that. You can have access to this reflection API for Android and Redux view model stuff. That means that, for example, if you want to declare view model instead of using the functional way, you want to use directly the type, you can do that. But be aware that you have to use the proper program rules. And also in terms of performances, you will see that API that is using the reflection, even for very small definitions, it's 4 to 10 times faster to run in the functional way compared to the reflection API. Yeah, you can test it, but you will see that the difference is very interesting. And then that's the question. Let's migrate everything to Koin. Yes and no, because you can, for example, what you can do is you have an existing application, and what you can do is you can begin to declare one portion of your graph in Koin and keep the other the definition in other solution. And what we are doing is that we can use the Koin component interface to directly inject by property the needed definition. And after that, you can disconnect the graph one by one and declare everything in Koin. But this is not always like that. I mean that when you want to test another solution, when we talk about dependency injection, it's really a big problem here, because you can't say, okay, boss, I just take 3 weeks of refactoring and we are just changing the DI. No, this is not possible. And we have a user survey that runs from September, and the top one issue was it's really hard to switch from the DI, clearly. And it's really problematic when you have lots of code that has been written around Dagger or other solutions, and it's really hard to go away from that. And finally, most of my success story were don't try to refactor directly. If your application is running, keep it like that. What you can do is introduce new feature, and then you can play with new feature with new modules that you are introducing. What we are making in those moments is that we can make dynamic module. That means that, for example, I have a, let's say, a financial application that is dealing with cards and stuff and transaction and blah, blah. Okay, we have lots of stuff. What we can do, instead of trying to refactor everything and trying to convert everything to Koin and just pure Kotlin, what we can do is, okay, first I have to use modules and stuff and try to understand that my applications has to run in terms of module. And I can change one module for that. I can add a module directly for new feature. And also we could just A/B test for critical parts to say, okay, finally I have two modules, a new one, I begin to write new stuff, and I have a new one, then I try to finally shortcut the current code to the new code. And then instead of refactoring, best is to try to just add new features, new modules, and then use them one by one. And the magic behind that is that if you have a container and application, finally with Koin, you can start Koin, you can load definitions on the fly directly, and also you can unload them directly. That means that we can just say, this module, I want to remove them completely. And the main magic is that here, we can load and unload dynamically modules definition, and then you can change on the fly your implementation. And then it allows you to compose step by step with little modules and then run the stuff one by one. But you have to be prepared that your application have to run in terms of module. You have to be sure that you have isolation with library and stuff. And for Android, you have to take care about navigation, feature flagging, etc., etc. I think this is a very good topic for one next talk. There are lots to do here, but this is not done like that. But this is the path to go then. You have to begin to inject external Gradle module and then try to add stuff to your application instead of trying to break everything at once. Okay, then what's next? We have this roadmap for the next version, and I would say that 60% of that had been filled by the community, and which is good because the community is really active around that, and people like to contribute, and the project is simple enough to be open for that. One of the other stuff is that Koin will be multi-platform, and I'm working on that actively, but we have to take care about the new native multi-threading stuff that force us to understand and to rewrite our way to deal with the graph and immutability and stuff, etc. But then it's on the road, and then Koin will be multi-platform. Yeah, that's it for me today. Just for you, some takeaway, and for the people that never used Koin, that is, you have getting started project. You can just have project that you can download directly from GitHub, and you can try just Koin directly in 2 minutes, 2 or 5 minutes. You have directly documentation on Light, which is you have the straightforward topics to go. And the main idea is just add Koin step by step, and then after that, scale. And don't forget to check your modules, and don't make your modules being really some kind of nightmare and factory. Keep them simple. All your modules are configuration, and you have to keep them clean and simple. Try to not abuse about platform extensions also, and if you have any problem, Stack Overflow, GitHub, Slack. We are on the Kotlin Slack language stuff. We have a channel called Koin, and you have people on that. The project also has a Twitter. You can follow that. You have a developer blog on Medium, and the most important thing is that we need your feedback. That means that this project has been launched in 2017, just in the first moment, but finally with lots of feedback, lots of people that come to contribute from every ecosystem, lots of people from the Android community, and yeah, this is really impressive to see lots of people contributing to that, and clearly I want to thank them for that. If you want to set up your Gradle project, the current stable version is 2.1, and the unstable version is 2.10 alpha 1, soonly alpha 2. And if you want to use Koin just for Kotlin application, you have the Koin core stuff. Just for Cater, Koin Cater, and also don't forget to use the SLF4G logger. For Android, you have Koin Android and Koin Android view model. You have also the Android X declination. This is a Koin Android and X and Koin Android X view model. And don't forget to make tests also. It's good. Everything is available on the website. This is just insertcoin.io. And if you really like Koin, just spread the word, please. Thank you.